So hello, I'm Max. I'm now with Celonis for 3 years as a working student, and I'm now going to talk to you about the build and test environment at Celonis, and more specifically of the query engine, which Philip already mentioned, which is basically the database engine that reasons over the data and answers the queries of the users. So I want to show you like an overview from 2016 to now, how our build system changed, how we adapted, what were our changes, and what we learned from it. So we start with our 3 platforms we had to support. It was Windows, Linux, and macOS. And in the beginning we had, as like build systems, we had Visual C++ project files for Windows, and for the Unix OSs we basically had CMake. For dependency management we had, we just checked in the dependencies. It was pretty easy to do in the bootstrapping process. For builds, there were only like some people building stuff, so usually the most senior person in the team would fire up a laptop and then build like the whole software for the people to consume them. The testing was basically just custom, so whenever some testing stuff came up, people just wrote like some frameworky stuff and just extended the testing whenever they needed. And for deployment, we just checked in the binaries into the repository. So if people cloned our repository, they had like latest binaries and could just run the software. So, lessons learned. Multiple build systems is usually a bad idea. Like, you can see the technical debt almost immediately. You see that, oh, I have to add this new dependency. Oh no, I have to change it twice. I have to twice find out how does this build system work, how can I change this. So it's a lot of overhead almost immediately. Checked in dependencies, they are cool because you can do git clone and then everything just builds, but like in the long term, you have to carry around or like complete boost or like some other dependencies, and it usually devolves into it's hard to maintain, it's hard to figure out what do I have to check in, what don't I have to check in, and so we pretty fast figured out this is bad. CI is important, like the most senior developer in the team firing up the laptop, maybe he's not around or something like this, or maybe like somebody needs actually a build and we cannot tell everybody how to like press all the buttons correctly. So CI is like a very important step for us, and we recognize this immediately. And binaries in repo, I guess if you know Git, you also know that binaries should not be in the repo. But we still see it today, because when we clone some old projects, we see the cloning times are huge, because like a lot of Git objects from just binaries get checked out all the time. First iteration. So the first and like best step was to just unify all the builds build systems under CMake as a meta build system. Then we switched to Git submodules for dependency management. It seemed really appealing at the time because you could just add like the repository to your repository. You would have the same feeling as checked in dependencies, but you would have still the separation in the cloning times. For builds, there were automated somewhat builds of the main branch. So we had some CI in position, and it built the software completely for the customers at least. And yeah, this was one step. And we switched to catch testing framework. There should have been a talk like some time ago about catch testing framework. And yeah, it was pretty good for us also. And checked in dependencies also went away. We packaged the binaries and just pushed it to a private repo. Lessons learned. Git submodules are cool in the beginning. They are cool if you just say, oh, I just want to add this dependency. I just want to add it because I will never even change this anymore. But then, oh, you do have to change it. You do have to do some other stuff. You have to switch branches or stuff like this. And immediately you see the weakness of it, because it doesn't really adapt to like a corporate scale development process. Building only the main branch immediately told us, okay, this won't work. We had merge windows, and after that we get an issue on the main branch, and it's like, okay, who was the bad guy? Who did like the issue? And it was like, okay, how can we figure this out? We don't know where it broke exactly. And Git bisecting all of this is like expensive and time-wise. next iteration. So we switched to Conan packages. So I think there was also a Conan talk in the past, but it's like a Python-based C++ dependency management. And we partially pre-built all the dependencies and pushed it to a repo. So for the build servers and stuff and for the developers, they could just pull in the dependencies and then go right ahead. So we had like the feeling of checked in dependencies again, but a bit more organized. For automatic builds, now we just build more. Like the usual thing is, if you have issues with, oh, I have an issue, just build everything or build more branches. And so we started with release branches, like branches that got shipped to the customers, and pull requests that were then also built automatically. We switched to Catch 2 from Catch 1. So there are some new features, I guess, in Catch 2. We haven't really gotten around to it, but I just wanted to mention it like honorably. Okay, lessons learned from this iteration. Conan packages, they are nice and they have like a pretty thought out systematic on how to package dependencies into like nice logical units, but you have to really like feel the philosophy behind it and really think about how can I integrate this into my platform or into my pipeline, because it has to fit with their model of how dependencies work, of how versioning works and stuff like this. And also pre-building the packages is usually a task where you have to really think, okay, how do I pre-build, when do I have to pre-build this static dependency, when do I have to pre-build this dynamic dependency? And so, I mean, when the Conan people talk about Conan, they usually say, oh, it's pretty easy, but then they don't tell you about all the stuff that happens in like corporate settings. And just build everything. Like, if I could give you like one thing, it's just build everything, because we see then there's an issue on a branch where, oh, we didn't think we had to build this automatically for the developer, and then we figure out the error way too late, and usually it's not worth to like spare the build times on the server for a branch not to be built. And we also saw that testing is good and testing is fine, but benchmarking is like an essential part. Because as you saw before, we do have user interactions where the user sends us queries through our user interface. And usually now we have a test coverage where we get the results correct, but like we get regressions or performance differences from changes where we see, okay, some change in one operator of this query systematic really messed up the performance in another part. So when you go around and figure out testing correctly, or like that your test for correctness, then you should immediately go to the second step of we have to test whether one thing slows down another thing. So last iteration, we got rid of macOS. So this was a good iteration because it like lessened a lot of problems. Then we try to just pre-build everything. We see that it's just never worth if like one package is not built and then the developer has to build it manually or stuff like this. So we're really trying to figure out right now to get all the platforms we need, to get all the developers on board with it, and to really get them all the dependencies shipped. And just build more stuff, like build all the branches, all the PRs, add some sanitizer tools. So we think about sanitizer tools and, okay, does it make any sense? And then, okay, we just add it nightly, and then we just build our whole project with it. And also static analysis tools, like if there's one tool which seems reasonable, we just add it if it's not that much of an overhead. You usually just win. And then, yeah, as I said, thinking about testing in the development pipeline more as benchmarking and testing, because usually, or with the users, if they want to see, like if you want to interact with our software, they usually say, okay, it should be correct. I mean, there's no question for them, but like it should only also be fast. And if it's not fast, it's a breaking issue for them usually. So it's really important for us to know. So this is like the current iteration. We are still working on some stuff, but I want to give you the overall lessons learned. Iterative changes. So if you are in a corporate environment or like a big team environment, stuff like that, you cannot just start over and say, oh, I figured out this build system functionality, but I now want to just go over again. And it only works with iterative changes. It may be hard to like accept for me. It was also hard to accept, but like you cannot change everything over one night. So iterative changes are key. And think about developer experience. The main customer of your build system is always your developers. And if the developers have to learn like 7 hours of build system stuff, then something is wrong. Like it shouldn't matter what you do in build-wise. It should be really easy for the developer to just get going and just build the software and yeah, get going with the work. So, thank you. And are there any questions? Yes?
So I was eagerly waiting for the time where you spoke about the CMake box. Like, have you talked about this?
I mean, I guess this falls into iterative changes. So I guess maybe in the future, thinking about how to go ahead. Right now we see CMake as really powerful. And also the Conan integration is like a killer feature for CMake actually. So, and yeah, I guess we have to think about it and maybe make another iterative change like in 1 year or something like this.
But how has the way you write CMake changed over these years also?
What? Sorry?
The way you write the CMake part. Because like CMake is like very big, you can do many different things in it, there's different styles of it, right? Has this changed over time, would you say?
Yes, I mean you develop some kind of best practices as like a company, but we also take like inputs from other sources on how to write proper CMake or like to fit in with the philosophy of CMake, because I think you really realize that you mess something up if you deviate from the philosophy the CMake people think on how the build system should be implemented. And so it's like trying to figure out what the best practice is. But it definitely changed from the early bootstrapping days. Yes?
You mentioned you were doing benchmarking. How do you actually track your benchmarking? How do you actually do that?
Well, this is a bit of an still ongoing project, but so the idea would be to have like micro benchmarks for the internal code and for the grand scheme, like what you saw from like the application, to have bigger benchmarks where we do the same thing as the user does and then run this nightly and keep track of the changes, like commit-wise, and then maybe find some deviations.
You're doing this in Enviroment?
I think we haven't yet set it up fully.
Okay.
Yes.
How long does your build system take for one line commit, one line change until it's merged into master?
Well, I guess this is more of a code review thing, but like.
No CI.
Oh. Well, I'm not really sure of the specific time, but usually we run first like some static tools that we run before for the pull request that the person would do for the one line change, and then build for all the platforms, and then the person would see, okay, my build was green, and then the reviewers would usually get done, and then it would be merged, and then it would be built again. Yes. So I guess like for static build tools, like I think 1 hour or like 3/4 of an hour, and then for the full build, it's like maybe half an hour or 45 minutes again. No more questions? Okay. Oh.
How do you manage the evolution of your library versions?
Oh. What? Sorry.
So how do you manage evolution of your libraries? Obviously, if you build software with a new version of the library, you want to check that it doesn't break your build, right? Doesn't use some bugs.
Okay, so the question was how do we add like new versions of libraries, or how do we test it? So right now, Conan allows you to have different channels, I think, for dependencies. And so right now the thing would be to push it to a different channel and then just write on the Conan file. But I guess locally is still a lot more used right now, so people just test locally whether the dependency in the current version works. Yes?
Not a question, but a comment. It was a great lightning talk.
Okay, thank you. Okay, thanks.